This presentation video is part of our DDWR2343 building service course, focusing on staircase study. Our group has conducted an in-depth analysis of the dot-legged staircase in building T05. First of all, I'd like to introduce myself and my group members. My name is Cha, and the group members are
Liu Minglun,
Daniel,
Eiffel,
Leong Ik-shun.
So now I'm going to introduce our staircase, which called the dot-legged staircase. And this staircase is actually 180-degree bend, and usually at a landing halfway between floors. And this staircase is actually located in T05 property building, which is in Beauty and Skudai. So the building and the staircase is using modern era style, which evolved to fit diverse architectural styles for minimalist and functional to organic and sculptural design. About the material used and the design feature. So the main material to build this stairs is that actually using the carbon steel, which is a combination of two elements, iron and carbon. So carbon steel is the most common material to use to design metal stairs, and it is cost effective, extremely strong and durable to support complex stair designs, and can be finished with many types of coatings. And this stairs has been divided to three parts. The first part is the diamond plate stair tread, which is cost effective for industrial and service stairs. The next one is the multi-line railing. The function of this is that it's very durable for commercial stairs. And the last one is the steel plate stair stringers, which cost-effective stringer for surface and egress stairs.
Today I will be presenting the design and technical detail of a dot-legged staircase. First, let's go through the right view and left view. And last is perspective view, to understand the overall form and structure of the staircase. To the section drawing, we can analyze the key measurement of the staircase here. The handrail height is 900 mm, ensuring safety and accessibility, and for the landing width measurement is 155 mm. And for each riser is 130 mm, and the tread depth nosing is 350 mm. And from the plan view, we can see that the landing length is 3300 mm, and the staircase consists of total 38 steps, making it suitable for multi-story circulation. This is our isometric view for our 3D model. If you want further detail, you can scan the QR for animation video of our 3D staircase.
This page outlines the roof of thumbs calculation. The staircase design using the formula 2 riser plus tread equal to 24 to 25 inches to balance riser height and tread depth. An example calculation shows that the staircase in building T05 exceeds the acceptable limit by 10 mm. This indicates that the staircase does not comply with the roof, ensuring safety and comfort.
Moving on to the identification of weakness that the staircase in T05 building have. The staircase of T05 have several weaknesses in terms of several aspects. Some of the aspects are in terms of material, texture, climate, appearance, and sensory. While carbon steel is a popular choice for metal staircase due to its strength, durability, and cost-effectiveness, it also has several weaknesses that need to be considered. The first aspect is material. The material of the T05 staircase is basically metal, and metal is exposed to corrosion. The metal stairs are prone to rust and corrosion when exposed to moisture. Other than that, the material also is high in conductivity, which means the metal staircase are easily transfer heat and electricity. The second aspect of the weakness is about the texture. The staircase at T05 building has a diamond plate texture. However, even the staircase has a diamond plate texture, it also becomes slippery when wet. The tread can still become slippery and wet during rain. Based on our observation, we have seen someone slip down the stairs during rain because the tread of the stairs is slippery. Moreover, we also found out that the handrails is also slippery when it comes to rain, so it is quite dangerous for the users to use the stairs when it comes to rainy days. The next aspect is about the climate. As the staircase at T05 was made of metal, sometimes give an unpleasant feeling to the users, especially during the hot and sunny days. Due to the heat that been absorbed by the staircase, the handrail becomes very hot and it made the user become unpleasant when touching it. The next one is about the appearance. In terms of aesthetic, some people may find it less appealing compared to the wood or other materials. And the last one is in terms of sensory. Based on our observation, we found out that this staircase is noisy when walked on because of the hollow space underneath the stairs. To be specific, the steel plate stair stringers are noisy.
Today I will be presenting the compliance status of the stairs in UTM T05 according to the Uniform Building Bylaws. I will be focusing on three main aspects: staircase dimensions, handrails, and maximum flights. The first one is dimension of staircase. According to UBBL 106, the stair riser height should be not exceed 118 mm, while the tread depth must be at least 255 mm. Additionally, landing depths must be equal to or greater than the staircase width. And the first one is open surviving UTM T05. We found that the riser height is 113 mm, which complies with the UBBL standard. The second point is the tread depth is 315 mm, which also meet the minimum requirement of 355 mm. The landing depth is 1550 mm, which is not less than the staircase width 3300 mm, making it comply with UBBL 106. So overall, the stay in UTM T05 comply with UBBL 106. And the second one is handrails. It is UBBL by law 107. UBBL 107 stated that the first one is every staircase with 4 or more risers must have at least one handrail. The second point is the handrail should project no more than 100 mm from the wall and be located between 825 mm and 900 mm from the stair tread. The third point is handrail at landing must be at least 900 mm height. Over surveys show that the stairs in UTM T05 have at least 100, so they comply with UBBL 107. However, the handrails project no more than 100 mm from the wall and are within the required height of 825 mm to 900 mm, meaning they do not fully comply with UBBL 107. The handrail on landings are 900 mm above the landing, which meet the compliance requirement. Thus, while the stair handrail mostly comply, adjustments are needed to fully meet UBBL 107. The third one is maximum flight. UBBL by law 108. UBBL 108 states that for resident building, the landing depth should be at least 1.18 meter, so that it is 1800 mm So no staircase flight should have fewer than 2 risers. From our surveys, the landing depth in UTM T05 is 1515 mm, which is less than the required 1018 mm. So it does not fully comply with UBBL 108. However, the stair flight contain at least 2 risers, meaning they comply with UBBL 108. Overall, the stair flight meet most requirements, but the landing depth need to increase for full compliance. Now is the last of the UBBL by laws 110, which is no obstruction in staircase. So the first question is, there shall be no obstruction in any staircase between topmost landing thereof and the exit discharge on the ground floor. And the answer is, the stairs in UTM T05 comply with UBBL 110 regulations, as there are no obstruction in any staircase between topmost landing thereof and the exit discharge on the ground floor. The second question is, there shall be no protection other than handrails in the staircase in any corridor, passage or staircase at a level lower than 2 meters above the floor or above any stairs. And the answer is, the stairs in UTM T05 comply with the UBBL 110, as there are no protection other than handrails below than 2000 millimeters, and each riser height is 130 millimeters.
Here are some reflections from my group member and me based on our study of the staircase. The staircase in T05 does not follow the rule of thumbs, as the resulting measurement exceeds 10 mm.
From the study, I learned how to use a steel structure to build a staircase, benefiting from the cost effectiveness.
As for my reflection, I found out that the staircase can be found with some weakness when users have to consider their safety from getting fall by slippery tread. However, even the staircase have several weaknesses, some of them can be improved. For example, as for sensory, it can be properly insulated and covered with noise dampening material to avoid noisy sound when walked on.
So, from the reflection of this project that I studied, I learned that building a staircase is not an easy project. You need a lot of consideration to build a simple staircase. And for this T05 building staircase, it needs a lot of changes due to his safety issue.
For the summary, the stair in UTM T05 mostly comply with UBL regulation. However, some adjustments are required. Particularly in the first one is landing dip should be at least 1800 mm. The second one is the handrail protection comply with UBL 107. The third one is ensuring tread dip remains consistent with standard. With this modification, the UTM T05 stairs can achieve full UBL compliance, ensuring better safety and usability. Thank you.